All right, section 10.6, parametric equations. We're supposed to grade homework. My little sophomores just tuning in. Sorry, you're not little, but maybe you are. Hopefully pre-ACT went well. My freshmen or sophomores? Do I have any freshmen in this class? I don't think so. But my pre-ACT kiddos, hopefully it went well, and you busted through that math section, and I suppose the rest of it. But we're going to grade, and hopefully you guys are grading with us. We're going to go pretty quickly. I'm trying to get the upperclassmen a work day, which would be nice. I'm trying to get them a work day, which will be nice. Okay, here we go. Section 10.6, number 14. You should have had a parabola, and careful, did you put orientation arrows? Because it was moving from the upper left to the upper right. And then they just made a quick table, but they also eliminated the parameter. Remember, we isolate, get T alone. It's a dark and gloomy night. Spooky, spooky. But anyway, get T alone, plug it in, and then you have your final eliminated path. Or the parameter has been eliminated. You have your path in terms of x function mode. Number 28, very similar, except this time you have trig. And from what you saw yesterday, you should have known this was going to be some sort of ellipse, but you could have plugged in like unit circle values and gotten points. You could have gotten points. Orientation arrows, it was going counterclockwise as you graphed the points in increasing order. But then solving, hopefully you would have subtracted or added, divided, and then plugged into cosine squared plus sine squared is 1 from yesterday. Number 44 was just like a, hey, can you use your calculator? But did you guys see it was a hyperbola? Conic sections have parametric equations. Any questions on calculators? It's okay. That's okay. Any questions on how to use your calculators, or were they working okay? Okay. Number 58 was just like that homework example we did at the very end of yesterday. I think it was here, where you were given clues and you were supposed to get to the equations. And so let me go ahead and just show you what they did. They figured out their center was 3, 3. Sorry, not 0, 0. Was 3, 3. Their major radius was 4. Wait, was this the exact same problem? Spoiled rotten. If you didn't notice that, sucks to be you. And then we go to 10.7. Spoiled rotten. Okay, any other questions? No? Evens or odds? We're good? Okay. So underclassmen, if you guys had any extra questions on homework, bring them tomorrow. I'll check in with you really quickly and make sure that we're good before moving on to 10.7. As I told you yesterday, we're going to do a little bit more 10.7. We just learned how to graph these r's and thetas. Remember, quick heads up, if r is positive, we are headed towards the angle, and if r is negative, we're headed away. Quick example, if you see someone in the hallway and you're like, I like you, you have a positive relationship with them, maybe you'll go towards them. If you see someone in the hallway you have a negative relationship towards, you might be like, I'm backing away, I'm going the other direction. Or you could, be childish like that too. Okay, so what I didn't show you yesterday was how to graph points without one of these really snazzy polar graphs. But I said I never wanted you to have to draw one of these entirely again. So we're going to learn today how to draw polar points without one of those big old polar graphs. Okay? So polar points without a big old polar graph. You just work through, and you only graph the information that you need. You only graph the information that you need. So guys, what's the farthest out I could possibly be going? Think of it like you're on the North Pole. You're on the South Pole, and the radius is how far out you move in who knows what different direction. But how far out could we possibly go? Yeah, 5's the max, right? So I'm going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Only graph what you need. And the farthest out I can go is 5, so fine, I'll graph 5 in any and every direction. So now let's go ahead and work through point by point. To graph 5, 0, do I need to add any angle lines? No. All I need to do is go ahead and on the 0 degree mark, go out 5. Well, that was easy, right? Now, for the next one, for 3, do I need an angle degree? Yeah. What do I need? Okay. Can we approximate 30? Sure. And if you want, you can go the opposite direction, because depending on the radius, maybe we're headed towards and maybe we're headed away, right? But how do we do 3? Do we go over 3 and up? No. Do we go up 3 and over? What we do is we think about if there were concentric circles, we go out. Imagine, where's my 3? 1, 2, 3, 4, 1, 2, 3, 4. Oh, I lost my 5. Sorry, lo siento. Doop. There we go. Okay. Now I can connect my 3s. So 1, 2, 3. Imagine you had done all of them. And imagine if you were twisting that 3 where you would land, and that's where your point. You could go up 3 and go out 3 and curve around and meet and say, where does it intersect? Oh, about there. There's my point. I don't need to draw all of them just to get that one. I just need to think about how the graphing works. How about for 160? Do I need an angle line? Yeah. Okay, so how would you guys tell me, how would we get the 1? Think the unit circle, or think connecting all the ones with the circle, right? If we connect all the ones with a circle, where would it intersect the 60-degree line? Wouldn't it intersect right about there? So you could, if you want, you could draw that circle. And you could just see the intersection yourself and then go. Or you could just do the rotation and get to where you're understanding. I'm just looking for where the circle of a radius of 1 would intersect 60. Okay. 0, 90. How hard is that one? What happens if r is 0, whatever the angle is? 0, 210, 0, 360, 0, 135, 0, 120, 0. If r is 0, have you gone anywhere? No. So maybe you turned, but you're still on the pole. Maybe you turn this way, but you're still on the pole. So anytime there's an r equal to 0, you're right back here. Now, do you guys see how we kind of go in that direction? Polar points don't connect like connect the dots. They don't go straight lines, straight lines, straight lines. That's not polar. Polar is all about rotating and curving. Now, they can make straight lines. It's very rare, but they can make straight lines. But usually, they're making curved graphs. Okay, 120. We need a new angle mark, right? 120 is 2 360s. But what do I do when it says -1? Yeah, negative relationship. I'm backing away, right? So instead of going out 1, I'm going to go back 1. I'm going towards the other direction, which technically would be what? 3, if I add 180, 300. I'm going away from 120, which means I'm going toward 300. I'm going back. See it? So I could, once again, draw my radius, or I could just be like, no, I get it. I'm just connecting the ones, seeing where it intersects, and then graphing. -3, 150. Don't I need more angle marks? 150 would be 30 degrees away from the axis. Going backwards, because it's a negative radius, adding 180 would be 330. Going towards 330. And I'm going towards it, not 1 radius, not 2 radii, but 3 radii. And then -5, 180. Well, here's my 180 right here, but I'm going the other direction. Isn't the other direction of 180 360? Wouldn't it come right back? -5, 1, 2, or 5? Yeah. Oh. Well, look at that little guy. Can you guys do me a favor? Can you pull out your graphing calculators? Can you go to polar mode? P-O-L. Can you go to polar mode? P-O-L. Can you go to polar mode? P-O-L. And can you graph the graph for 5 cosine of Let's do five cosine. Of 3 theta. Supposed to be something similar. Hold on.
Is it 3 by itself and the theta by itself?
It's cosine of, like in parentheses. Why don't you just try 5 cosine of theta? It's not exactly this graph, but it should be close. It's not exactly this graph, but it should be close. Let me pull up on Desmos real quick. I think Desmos does polar graphing. Let's see. Does Desmos do polar graphing? To change the graph paper to a polar. Okay. I can change to polar somehow. Oh, there we go. Haha, polar. Okay. So you guys can do r equals 5 cosine of theta. See, that's roughly, but I need it to be a little bit more squished. That's why I was thinking 3 theta. That's a little bit better. Because we didn't keep going, right? We only did part of it. We only did 0 to 180. Now, technically, this should have happened in this graph. It should have happened between 0 and 120. So this one's a little bit different. Let's see if I can do r squared equals 5 cosine theta. Oh, it doesn't like that. What if I do r equals the square root of 5 cosine theta? Oh, no. That would need to be 25. And then r equals the negative square root of 25 cosine. Yeah. No, it's all weird. Anyway. Stink. I can't get you a perfect graph of this one. Sorry, guys. But that's similar. That's similar to what we did. We just kind of did it in a more squished fashion. So we would have to do something like... Yeah. But like this equation gets me a circle. It doesn't get me like a weird ellipsy thing. But do you guys see how all those things I just graphed, like even when I did like cosine of 3 theta, there's like a little baby rose, or cosine of 4 theta. Ooh, that one's fun. Or we could go out to 5. Or we could do cosine of 2 theta. Or cosine of 6 theta. That one's fun. Cosine of 5 theta. Do you see how all of these are formed by rotating? Like you're going to go different points, then you're going to like finish petals, and then you can make more petals depending on the equation. And this is only one type of equation. We could also do things like 2 minus 3 cosine of theta. Now, that one's called a limaçon. We could do something like 1/2 theta. Ooh, we could have a spiral. That's kind of exciting. But do you see how a lot of these graphs, now I could do something really weird, if I remember how to do it. Let's see, is it secant of theta? Yeah. You can get straight lines, which are super weird and super awkward. However, most of what you're doing in polar is going to have some sort of rotation, some sort of spiraling, some sort of rotating. Kind of cool, huh? So then coming back to our graph. Did we need this guy with all these concentric circles perfectly ready for us to go? No. All we needed was enough for these individual points and the angles for these points. And then remember, when you go to do the R, we're not going over and up. We're not going up and over. We're not doing X, Y. We're doing out 1 radius, out 2 radii, out 3 radii. Wherever it intersects, that's our point with the angle that we want. Or if we're doing a negative radius, remember we're going away from the angle 1 radii or 2 radii or 3 radii like this one. Does that kind of make sense, guys? So this isn't a perfect graph of that equation. I'm taking the equation away, but it is kind of a similar idea as a lot of the ones I just showed you. Let's save that one maybe for a back of the spiral and make sure that our sophomores actually watch the video, huh? Then you guys will be able to ace it tomorrow. Whoa, but it's in radians. That's okay. What do you do with radians? Should be easier. At least like it's familiar, right? Pi over 4, we know where that is. Psh, pi over 2, got it. 2 pi over 3, psh, pi, psh, 3 pi over 2, psh. Okay. Let's talk just a little bit about converting because that's going to help with homework a lot. I'm not going to do everything. I think I'm just going to do this page and maybe one example and then let you guys start working. So, converting. Using the right triangle. Did we just talk about if you were at the pole, and if you're turning an angle and going out a directed distance r, going out is like diagonal towards whatever angle you have, right? Your theta is out here. We turn theta and go out r, but couldn't you end at the exact same point with some x and some y? I'm going to come back for just a second. Over here when we graph this point, like this one right here, we turned 30, we went out 3. Got him. But would there have been some x that could have signified how far over you would go? And couldn't there have been some y that would have signified how far up you would go? But the x wouldn't be 3, because 3 was the hypotenuse. And the y wouldn't necessarily be 1. We'd have to solve for it. But how would we solve for it? Well, couldn't we just do good old-fashioned Pythagorean theorem? Not with this. Couldn't we do good old-fashioned trig? Sine is equal to opposite, or the y over hypotenuse, or cosine is equal to adjacent, or the x over hypotenuse. Does this sound a little bit like vectors? Not in a stressful way, just it's a right triangle way. So how do we go from polar to rectangular? Well, if we have r and if we have theta, so polar, if we have r and we have theta, that's what we're given, and we're trying to go to rectangular, trying to go to xy, we would need to think about how x is equal to r cosine theta and y is equal to r sine theta. And these are equations that should not be unfamiliar to you because we've done right triangle work a lot with vectors, with complex numbers. Huh? Sure. We can do polar to function mode. Rectangular. I'm putting the wording because I don't want you guys to be confused when you see the homework problems, right? If you have x, y, how do you go to r theta? Well, can't I just do x squared plus y squared is equal to r squared? I can solve for r with Pythag. And technically, r is equal plus or minus squared. Because r's can be positive. Length, or they are, but they're talking about length like in a certain direction. I can have a positive r get somewhere, or I can have a negative r with a different angle get to the exact same place. So technically we are able to let r plus or minus. And then for theta, I'm going to say use tangent inverse of y over x. But just like we've had to do multiple times with theta and with tangent inverses, we have to remember that tangent inverse is only going to be, when you use your calculator, if it's not unit circle, remember it's only going to be in between 90 and 90. Oh, sorry, and those are vertical asymptotes. It's actually never going to be 90 or negative 90. So if tangent inverse is going to be between negative 90 and 90, remember, we might want an angle that's in the second quadrant or in the third quadrant or in the fourth quadrant going the other direction. So we're going to use this angle, but we're going to use the angle and symmetry to get the one that we want. Or we're going to use the first and the third quadrant, the first and fourth quadrant and make it a negative r to get to the other quadrant. We actually have more options now since r's positive go one way and r's negative go another way. And so just to get you started off, we'll stop here today. This says from polar to rectangular. So first, my brain has to figure out who is this guy. This guy is r theta. Whereas this one says from rectangular to polar, so this guy would be an x and a y. So how would I get to x and y from r and theta? So I can say x is equal to r. Isn't this unit circle? (11 pi over 6), isn't it? Almost 2 pi, right? 11/6. Oh, it's right there. Well, if it's only 1/6 away instead of 1/3 away, it's a 30 degree. It's a pi over 6, which is the first one in our cheater chart. So sine goes first. 1, 2, 3. Cosine goes next. 3, 2, 1. So I need square root of 3 over 2, whereas sine would be my 1/2. Oh, but careful. Hold on. Who's who? Cosine's going to be positive. The x is going to be positive, right? What's the y going to be? Cosine's positive, sine's negative. Good. So I end up with my rectangular point of how to get to this exact same location going out 1, 2, 3. I can get to the exact same location by going over negative 3 root 3 over 2 and going Why is this confusing? What quadrant does negative 3 rad 3 over 2, comma 3 halves put you in? Even if you don't know the numbers exactly, what quadrant are you in? Aren't you over here? If you go negative and a positive? How does that make sense? I thought we were supposed to be down here. Why are we over here? Why am I imaginarily circling the negative up here? What do negative radii do? Oh, come on, if you have a negative relationship with someone, you see them in the hallway, you're going to go running up to give them a hug? No. Well, maybe some people, but no. You would go the opposite direction. Isn't that where I'm supposed to be anyway? 11 pi over 6 is down here. And when I was plugging in for 11 pi over 6, it was valid that I was looking down here in the fourth quadrant. But when they put a negative radius, my point was actually backwards negative 3. Sorry, backwards 3. So does my xy make sense with my picture? Yes, if I graph it correctly. So then how do I do this guy down here from rectangular to polar? Yeah. I mean, I could actually graph it, right? Like negative rad 3 and positive rad 3. It should be in the second quadrant too, right?
Well, it's funny. You can make your...
I know where it's supposed to be, but in order to solve, I need to go ahead and say r squared is equal to negative rad 3 squared plus rad 3 squared. Pythagorean theorem, easy, elementary stuff. Well, maybe middle school stuff. But either way, isn't that 3 plus 3 is 6? So r is equal to plus or minus rad 6. Theta, I'm going to use my tangent inverse of rad 3 over negative rad 3. But guys, what does thing over itself always end up equaling? 1, right? If you throw this in your calculator in degree mode, guess what it's going to give you? No, it's going to give you negative 45 degrees. which is the same thing as negative pi over 4. So how do I take this clue and this clue and make some polar points? Polar points, like more than one? Yeah, 1x, 1y. Zoom, zoom, done. That's it. Polar points, there's infinitely many. Someone give me some point that will land me right there. What's one way of getting there? Give me an r and a theta that would land me in that spot. Do you have one, Kim? What would land me there? How could I get there? I know that r is plus or minus rad 6. I know that the theta is negative 45 or negative pi over 4. Jason or Jaden, how could I get there? Well, I have to go a specific r, though, right? And I have to be on a specific theta line. I can't just be at any theta. Huh? Somehow combining these to give me an r and a theta that would land there. Yeah, just one. There's lots of different options. What's one way of landing in the second quadrant? I don't know. Use the numbers that you have. So we have two options for r, either root 6 or negative root 6. What do you want it to be? Sure, positive root 6. Okay, if you're choosing a positive root 6, that's going to be going towards an angle. So I need an angle that I can go towards. I need this angle in the second quadrant. Right now I have this guy in the fourth quadrant.
Oh.
Yeah, what is that angle? I'm in the fourth, but I need to go to the second, because this is a negative x and a positive y. This is the point that I need to get to. Kyle said he wanted to choose a positive root, which means I have to go towards that. So what's an angle? You could do negative 225. Is there an easier way? Okay, now give me another way to get there. Do it with a positive. You could have also gone a positive direction instead of a negative direction, right? What's the positive angle that's in the second quadrant? Couldn't we do 3 pi over 4? You guys don't have to do degrees. You can do radians. Wouldn't that be second quadrant going out towards? What's another one? Well, hold on. Negative rad 6, you have to go away from an angle, which means I can't choose the second quadrant angle. I need to choose the fourth quadrant. Oh, these were fourth quadrants. Can I make it negative 45? Right? Negative 45 backwards. So you can go positive 135 out. You can go negative 225 out. You can go negative 45 back. You can go negative, well, that's just the same thing, but in radians. But I could go all day. Why? Because I could start adding 360s. And I could, like, on the person on the North Pole, I could start spinning them in lots of circles and then have them run. Maybe they won't get there straight, but I could have them run, right? Or I could have them spin the other way. How many points can make one location in polar? Infinitely many. So when homework says, get me a polar point, you get to choose. Just make sure your point lands in the right spot. Does that make sense? Cool. All right, cool kids, here's your homework. Boop. Nope, that's not it. Isn't that fun? Here, I'll have even more fun. What if I go ahead and make this something like 1 over 5? Woo. And I can have it go even more. I can have it go to something like 60 pi. Woo. I'm going to hypnotize you all. All right, here we go. Homework is, there it is. All right. If you don't have a piece of paper, borrow a piece of paper. You should be in your homework spirals. Go play with homework. It's not due till Friday. Section 10.7 isn't due till Friday. Section 10.8 isn't due until after the break. And then our quiz is on 10.6, 10.7, 10.8. Well, some of them are just graphing points, like graph a point, graph a point, graph a point. You can do that all on one graph. Some of them are just something as quick as